Let's solve a differential equation called Bernoulli equations. So let's solve dy dx plus sine of x times y equals cosine x times y to the fourth. So the very first thing that I'm going to do is divide by y to the fourth by this term. So we get y to negative 4 dy dx plus y to negative 3 sine of x equals cosine of x. So the substitution that we are going to use for Bernoulli, and I'm going to shade it with green as the title, is z equals y to negative 3. And again, y is a function of x, z is a function of x. So dz dx equals negative 3 y to negative 4 dy dx. So this quantity here, which is the same with this one, right? We're gonna substitute it with negative 1 over 3 dz dx, right? If I divide this side by negative 3, I'm gonna get exactly the yellow one. So I'm replacing in here, right? I'm working on this equation. So instead of the yellow one, we put negative 1 over 3 dz dx plus the green part, it's our substitution. It's z sine of x equals cosine of x. So basically what we did, we transform it from an equation in x and y into one in x and z. So let's try and solve this one. So I'm going to multiply by negative 3 first. So dz dx minus 3z sine of x equals negative 3 cosine of x. So we have to think, is this equation separable? Well, if you are trying, I bet is not. Is this equation linear? Well, it looks like it would be linear, where p of x equals negative 3 sine of x. It has the form of a linear one. Why do I need p of x? Because I want to find the integrating factor, mu of x, which is e to integral of p of x dx. So it's equal to integral of negative 3 sine of x dx. So equals e to negative 3. Integral of sine of x is negative cosine of x, so plus 3 cosine of x. So this factor that we found here, we are going to multiply this equation by it, e to 3 cosine of x, because the idea is, so this equation, because the idea is we're going to get a perfect derivative on the left hand side. So let's see, e to 3 cosine of x dz dx minus 3z sine of x e to 3 cosine of x equals negative 3 cosine of x e to 3 cosine of x. So the left hand side should be the derivative with respect to x of z e to 3 cosine of x. So let's see, is that true? So if we differentiate this one, we keep this one, and then plus z e to 3 cosine of x prime. Yes, it's correct. Equals negative 3 cosine of x e to 3 cosine of x. Now again, this is a problem that I made up, so it might be tricky. So now we integrate with respect to the x, both sides. So we get z of x e to 3 cosine of x equals negative 3 integral of cosine of x e to 3 cosine of x. Now the problem is plus some c. So z of x is going to be, well, we divide by e to 3 cosine of x, so it's going to be negative 3 e to negative 3 cosine of x integral of cosine of x times e to 3 cosine of x plus c e to negative 3 cosine of x. And because I made up the problem and it's a little bit funny, this integral we cannot calculate it, or at least not with the knowledge that we have right now. But The idea of the Bernoulli equations is clear. So if we end up with some integral that can be calculated, then you go ahead and you actually calculate that integral. Otherwise, this would be our final answer for Bernoulli.